All right, thanks everybody. Hey, this is a new start to my Lunch with Larry series. We haven't done this in a couple years, and I just wanted to get started on this again. Some of the material has been refreshed. I'm Larry Sampson. Used to work for Siemens. Was the vice president of business development, really, for medical device at Siemens for 7 or 8 years. Ended up over the last couple of years working for Alcon, doing a big digital enterprise consulting engagement with them. I was their head of digital strategy. Now I've started a company called 8 LLC that is doing digital enterprise consulting, and we really needed to update and refresh some of these materials. So today is a discussion about design control, and I'm just going to start with a talk about frameworks and essentially what do we mean by design control, and in general, what are the steps that you would go through to develop a set of design control capabilities. So the first thing I really wanted to talk about is, the different frameworks, and not only the frameworks content, but also from a priority standpoint, how would you deploy a system like this? One of the things that I've found in doing deployments for big organizations is there's a tendency to get caught up in the detail of more advanced topics. And what I'd really like to do is talk a little bit about how to work into this process and what should come first and why. So just to clarify as we go into this process, there's 100 different ways for us to think about how to framework and data models associated with doing design controls. Really, this is a comparison of notes. So what we're going to do is have a discussion about likely ways that a person could think about how these things would integrate together, with the understanding that, just as an example, risk management is one of those things that I've seen it deployed in maybe 50, 60 different ways, lots of different nuanced ways of thinking about the problem. I'm going to present a way that makes good logical sense to me, but I'm really looking for any feedback that you have on, other ways to think about it, or questions on, good ways to deploy things, bad ways to deploy things, so that it's clearer to everyone, what the trade-offs are and how to get to a place where we can get reporting on sort of function all the way down to, lots and realization of product. So first thing I would like to talk about really is this deployment order methodology. And I'm going to say requirements management is sort of a 1B, and I'll explain why, but we really want to start in any major system like this deploying the baseline data. And I would argue that everything in design control really pivots around the requirements management. But in addition to that, we have systems modeling. And one of the things I've really found as we did deployment of a variety of different divisions is that most people don't have a really clear understanding of product function. And when I say a clear understanding, it's not that they struggle with an understanding of how to deploy a femto, how a femto laser works, or how a surgical handpiece works, but rather their understanding of how to construct an understanding of performance of the device in a formal way. How do we develop a set of functional diagrams that inform what the requirements management should be? If we don't have a good, clear understanding of how to do that systems modeling, what happens is when we go to deploy requirements management, it's not really clear where those requirements come from and how to get a complete set of requirements. So a lot of what I've seen is people write requirements and they kind of think, well, I got a ½ an inch worth of paper, that must be enough, rather than saying we have a set of functions and those functions have outflows and we're writing the requirements against the outflows. Once every outflow is covered, we have a complete set. So I kind of want to talk a little bit about systems modeling and how that plays into this, because I think it's very difficult to deploy requirements management without having any formal functional understanding of how the system works. So those two kind of go hand in hand. Next is really standards management. We have external standards and internal standards that provide us with a historical understanding of how we've solved problems in the past. And so what we want to be able to do is map those external and internal standards into our requirement set, so we can quickly get to a place where we have, 60, 80, I've seen as good as 91% reuse of requirements. If we can do that, then not only do we quickly get to an understanding of what we've done in the past, but also we're using requirements that have been built out of vetted sets of requirements, so that the quality of those requirements goes up as well. Of course, verification and validation is a big part of this. How do we gather the evidence that our device complies with our, quote unquote, definition of good? And finally, risk management. And risk management is one of these things where we're defining really what is needed in the requirement set to assure something bad doesn't happen to a user. Systems modeling is kind of the opposite of that. What do we need to go into the design to assure that certain functionality is delivered? But risk management's the opposite view. What do we need to make sure doesn't happen with the device? And so that's a little bit of a complicated question. And the reason I'm doing this in the order that I'm talking about here is because the simplest thing for us to deploy is really requirements management, and it's the baseline set of data. So if we're talking about order, I think we want to start with systems modeling and requirements management, deploy that first, get our baseline data in place, and then spin around this circle, risk management being last. And you'll kind of see that as I go through this presentation, that risk management is probably one of the more complicated topics, and I would say one of the more controversial as well. There's different ways to do it. Okay, so that's sort of the four that we're going to go through. I'm just going to give you a quick preview on each of these four, really 5 circles, so that you have a better sense of where we're going to go with the series as we go forward. And in the future, each one of these, we're going to expand on each one of these for a half an hour and really talk about, what it is exactly that needs to go into each one of these so that we have a comprehensive deployment methodology. Okay, so I'm going to talk a little bit first about systems modeling. Systems modeling is a discipline in which the output of it is really a formal understanding of how the function of the device interrelates with the other functions of the device. And so if you think of a function as a black box, essentially we're going to have inflows into that functions, and we're going to have outflows out of the functions. And what we're going to be writing the requirements against is really going to be the outflows. So any inflow is coming from an outflow of a different function. So essentially, when we go through and create requirements, what we're going to be doing is identifying the outflows of the functions, and those outflows each are going to be characterized by a requirement. So really what the requirements are doing is assuring that the outflows conform with our definition of what the function needs to deliver. And so this is the relationship really between the systems modeling and the requirements. And as we go forward and we talk about systems modeling, what's going to happen is we're going to have a relationship between the capabilities, the functional chains, which tie together requirements across multiple components of the system, and then functions as they're delivered in a component of the system, and how those relate to the deconstruction of the requirements, so that we have a very cohesive, clear understanding of what the relationship between the functional diagramming and the requirements diagramming needs to be. So the second capability is requirements management. And again, this is sort of the core of the system, in that not only do we have a set of requirements and a formal definition of how these requirements relate to one another, but also we're going to have an understanding of how, from a systems modeling standpoint, it interrelates. Now, one of the really important things about this, and I think one of the things people get confused about, is when they see a deconstruction like this, sort of in a V model, user needs to system, design, physical requirements, and then a process control. It's important to understand that this isn't a workflow. And I think one of the things, whenever somebody hears the word, especially software people, when they hear the word requirement, kind of hackles go up on the back of their neck, because they're thinking we have to define everything before we actually do any design work. And that's really not what this is intended to do. In med device, what we're looking to do is have a very, and matter of fact, one of the things when I talk to people at the FDA, one of their biggest complaints about submissions is they really don't understand from the submission what the device does. And what we're attempting to do here is to provide this formal deconstruction so that it becomes very clear to them what the device does and how we define what good performance is. It's not so much a workflow from the standpoint of we have to do user needs or design requirements before something else. More, it's just we're trying to get to, at the end of the process, a complete definition so that we can communicate to people that are stakeholders how this thing works and how we're providing the control that we think we need to provide. And so this deconstruction is really just the framework that we're going to pivot these other capabilities around. And hopefully at the end of it, we're going to have a complete set of requirements that fully characterizes and controls our understanding of how the device works. In addition to that, one of the things that you run into, especially in complex designs, is that you can have systems, you can have system of systems and system of systems, right? So we can have subsystem interrelationships, and what we need to be able to do is understand how something of a level relates to itself. And so in addition to sort of the refinement relationship level to level, we also need the capability of creating system requirements and nesting those system requirements into subsystems. That's true for user needs in that we have not only user needs, but intended uses, and the user needs define those intended uses. So we need that relationship inside of user needs, systems and subsystems, of course, and then design requirements. It's oftentimes what we end up doing is deconstructing the design requirement. You know, the design will include the following, and then we have a list of the following. It requires this sort of refinement relationship. So we'll get more into this in the next webinar next week, but this deconstruction is necessary for us to really understand that, you know, to encompass all the complexity of how different designs can, what they can require from a deployment standpoint. So we'll talk about that more. Again, now I'm going to start introducing this idea that the functional model, the capability, the functional chains, and the functions relate to levels of this V in a particular way. And when we talk about functional modeling, what we're going to do is show some examples about how capabilities are deconstructed by functional chains and how those functions are deployed in different components of the system, and how to kind of interrelate those both from a software deployment standpoint and what it means from a design standpoint. So we'll get into that more in the systems modeling. Now, external standards. When we talk about external standards management, what I'm really trying to illustrate here is very often we have these external standards. I'm going to say ISO standards are an example of that, where we have either product specific things or maybe process specific things. So 11135 is the ethylene oxide sterilization standard. That's one example. But also if you're building a transcatheter heart valve, you're going to have a standard that's associated specifically with transcatheter heart valves, or 60601's electrical devices for med device, right? So each one of these standards has clauses that we need to be compliant with. Well, one of the problems that you run into is those clauses step on, or those different standards step on one another. So I might have clause in two standards that put the same requirement for sterilization, and what we need to be able to do is process that in a way that explains how the different clauses in the different standards are going to be realized in the product type that we're going to be building. So essentially what we do here is we then do an atomic traceability to a normative standard. I'm going to call that, so the normative standard is really our internal company standard. How is it for pacemakers? How is it for, you know, infusion devices? How do we believe we should be applying these external standards to our internal normative standard? And so what we'll do is take each one of those external standards, we'll break them down by clauses, and then we'll do an atomic traceability from the clause to the requirement, so that that requirement can then discuss how each one of those clauses will be realized in the product set that we're going to build. So this is really the first step to getting to a place where we understand how we're going to be deploying those standards. So essentially what we're going to do then is we're going to take this normative or company standard and we're going to share it as a document, as a set down to the project. And what that allows us to do is abstract how we're going to deploy requirements from a product type standpoint from the actual product itself, because each product has slight differences that we're going to have between what is a normative company standard and the project itself. So in some cases, we may decide that a requirement that's in the library doesn't apply and we'll strike them. Or we might have things that we're deploying in this particular project that are different than the standard, and we're going to have some requirements that are new. And so what we need is, that's the reason for this three-level abstraction, is to be able to have a discussion about what we're going to do in general across the company or across the product line. Say we have 10 different pacemaker types. We might want to have some standardization for 80-90% of the requirements. But when we get down to the project, each project has something special as well. So we want to be able to differentiate the project itself from the normative standards. The real question that we want to get to here is, how is this project compliant with the standard? So we're going to have a reporting structure that basically says, we want to select the standard 60601, we want to select the project, and we want to show specifically the traceability between the standard and the project, and show compliance, the evidence of testing with that standard, so that we have a very rapid way to not only identify which standards are being consumed by which projects, but also how do we show that we're compliant with that standard at its current or some historical revision. So that's really what this is all about. It's a huge benefit in developing a project to get to a place where I can say quickly, am I compliant with a standard or not? This is something that people have manual processes. They identify business process owners, BPOs, that are associated with a standard, and then they have to go through manually and look at all these documents. Not only that, but the reuse question, how do we do reuse and how is that traced into the projects? That can result in, as I've seen, as high as 91% reusability across the product set. So it represents a tremendous improvement, not only in how fast you get to market, but also in the management of those projects over time. So that is, I think, an important part from a value perspective. Just to add to that too, I've been working with a compliance group over the last, year and a half, working on a pilot program with BSI as an authoring agent. And so if folks are interested in automating the process of ingesting the external standards, I would suggest you get a hold of me and we'll see if we can get you in the pilot, because one of the difficult parts of this is to be able to electronically pull in the standard, have it broken down by clause, and then be able to update that standard as new revisions come out and do differentials on what's needed to bring the projects up to current compliance with a new standard revision. And that's really what that program is about. So I just wanted to mention it on the discussion here. We'll talk more about it in subsequent sessions, but if you're interested in being part of that BSI pilot program, just let me know and we'll see what we can do to get you into it. This is just a quick discussion about VMV. Of course, part of the data model is getting to a place where we've identified the evidence that our device complies with our definition of good. And so part of the data model is going to need to be, how do we develop a test case? How do we develop test results? And not only that, but to identify the output part number, or the bill of materials item as an output as the device under test. So not only do we want to say, here's the evidence that this requirement, that our device complies with the requirements, test requirements, not only do we want it to comply, but also we want to identify what the revision of the output is and the revision of the requirement, so we understand as the design changes over time whether we're currently compliant with the requirement revision has been realized by an appropriate output revision. So getting that report in place is what's required is to have the V&B constructed in such a way as we can report on what is our current testing status against not only the requirement revision, but the output revision. Easy for me to say, right? So that's really what that part of the data model is. So risk management is a complicated topic, and again, that's why I put it last. But essentially what we want to do in risk management is take our deconstruction and we want to inform that by running FMEAs between the levels. So the system requirement has a function that's associated with it, and the FMEA then analyzes that system requirement to understand what design requirements need to be in place to assure the system requirement is met. Now you can imagine from a functional modeling standpoint, if I have a functional chain and I have different functions that are deployed in different components of the system, that design requirement is going to be associated with the functions. The system requirement is going to be associated with the functional chains. And so the design requirements are outputs to the functions, and that's what's required to assure that the system functional chain works as intended. So as we go down these levels, the FMEAs identify the risk and the mitigation requirements that are part of the design. And if we do this properly, those FMEAs become part of the mechanism for us to assure that the requirement set is complete. And so this is there's many different ways to do this, but one of the things we want to talk about is how do we get those FMEAs integrated into the process so that when we do an FMEA, it's not a spreadsheet on a side project that's sort of sitting in a, in a repository someplace that never gets updated. It should be part of the live data understanding of how the thing's deployed. So let's now talk about sort of the complete picture. So we have the dark green that is the deconstruction of the requirements in a V model. The gray is this risk management component of it and all the data that's associated with, what are the steps in a process, what are the, the cause and effect data that's associated with the justification of the different levels. All that data comes into the picture. In addition to that, we have this functional model, capabilities, functional chains, and functions that are interrelated and traced into the requirements at the appropriate place. So we understand where these requirements come from a product function perspective. In addition to that, then we have test cases, and those test cases are all related to the different requirement types so that we can show compliance to those requirements. In addition to that, we have the external standards clause. So each one of those requirements also is traced, if applicable, to an external standard. So we understand how in this product we're identifying the compliance to those external standards. And then we have the outputs. So in the PLM system, we're identifying the bill of materials and each of the physical aspects of the design. And we need to understand what is our device under test, or what is the physical aspect of the system that satisfies that requirement, so that we understand not only from a test case progression standpoint, what are the steps we need to do a test, but also what is our device under test that we're going to use as part of the test case to assure that that requirement is met. And that way we can get this report that basically says, here's the requirement, here's the test case, here's the conclusion, and not only that, this is the part that we used and the revision of the part we used to assure that we're compliant with that particular requirement. So that's really what the complete picture is going to end up being. And we'll get into a lot more detail about each level of this and how it is that you actually do this kind of deployment so that it's clear to everyone. So that's really my summary for the half an hour today. Thank you for coming. You can understand why major design control capabilities are all interrelated with the requirements now, and hopefully that helps to explain why the order of the design control webinar here as to what we're going to be presenting over the next several sessions, so that it's clear how everything interrelates with one another. Just to let you know a few things. The registration link here is for the whole series. So you've registered, if you're on this call today, you've registered for the whole series. Please feel free to forward this to anybody that you'd be interested in seeing the rest of the series. I'll post this on my YouTube channel. So we have the Lunch with Larry YouTube channel. I would say I just ask you to subscribe to that YouTube channel, mainly because if I get up to 1,000 subscribers, I can run the webinars on YouTube, and I'd like to do it that way if that's possible. But also I got my LinkedIn account. If you want to schedule a meeting with me to talk, this is a link to my schedule, so you can set up a meeting with me. I'd be happy to talk to you for an hour, whatever, and see what you're up to. If you want to send an email, it's info@eightdec.com. If you put in the subject information, it'll bubble right to the top of my email list. So hopefully that gives you a sense of design control, and thanks for spending the time today. Next session is going to be on requirements management. We're going to go into quite a little bit of detail of some of the nuances about, complex systems and some of the things I've learned about what needs to be in that model so that it integrates well with the rest of these questions as we've raised them. So thanks everybody today for the discussion,